we're going to redo the time series lesson we had because we missed because of the technical glitch that I experienced last time. So let's redo this. And these are the packages that we need for this: forecast, FTP3, want mode, ggplot2, XTS, TSM. Okay. Now these are the packages that we're going to use, not necessarily today, but in the coming sessions. And then if you encounter difficulty installing the TSM package, kindly use this. Let me just put some notes here. Okay. So Kevin Kotze is the one who developed this package. Okay, so let me just run these packages. Okay, and notice the TSM package has already been loaded also. Naka-library na siya. Okay. All right, quick review of what we have discussed so far. We said that there are generally three types of data as far as its arrangement is concerned. We have cross-sectional data, time series data, and panel data. Cross-sectional data is a snapshot of a particular several units at one point in time. On the other hand, time series is a data of one particular individual or one particular unit. So this differs from the cross-sectional because the cross-sectional focuses on several units in one point in time, while time series is one unit at several points in time. And the combination of a time series and a cross-sectional data is a panel data, which we're going to discuss also next week. Okay, so there are many methods in order to model a time series. And one of the best known approach is what we call the Box-Jenkins approach, or the ARIMA model. In this subject, we're going to use the ARIMA model. Okay, and we have learned in the past that AR stands for autoregressive, wherein you use past values of the time series itself to model or to predict the time series. MA stands for moving average, okay, and you're using past error terms to model the time series. And then there's an I in the middle for integrated. This refers to a model that where you difference the time series. Okay, and what's the purpose of differencing? The purpose of differencing is to convert the data, to transform the data into a stationary data. Okay, so here are examples. When you say an AR1 process, autoregressive 1 there stands for lag 1, which means that we are regressing, we are modeling our time series y sub t using the past value of lag 1 here. It's y sub t minus 1. Okay, so let me just annotate there. So you have this time series y sub t. Okay, and then we'd like to model, when you use an AR1 process, we're using a certain constant mu. Okay, others call it A sub O, it's the same. Okay, plus, okay, the past value, y sub t minus 1. Okay, and then it's multiplied by a certain constant, the slope, phi1, y sub t minus 1, plus a certain error term, epsilon sub t. Okay, so this is an AR1 process. We are regressing y sub t, the time series, on its past values. Okay, So on the AR2 process, on the other hand, we'll use two legs. Okay, so that's y sub t minus 1 and y sub t minus 2. Okay, so that's an AR process. An ARP process regresses or models your time series using P legs. So that means it will include y t minus p. Okay, p legs, whatever that p is. Can be 10, can be 5, it can be 4. So if it's 4 legs, then you have y sub t minus 1, and then y sub t minus 2, y sub t minus 3, y sub t minus 4. Okay. Any questions so far? Clear ba yung concept ng ano natin ng AR process? Paki-chat naman please if clear yung concept. Clear ba, guys? Hello? Any questions so far? Clear so far yung concept ng AR process? Okay, thank you, Samir. How about the rest? May I know from the rest kung... Okay, let me ask you one question. Ano ibig sabihin ng y sub t minus 1? Clear nga natin. What's the meaning of y sub t minus 1? Okay, suppose we have a series, no? We have, let's say, 5, 3, 2, 2, 6, 7. Okay. Suppose you have this series. This is your y sub t, etc. Now, when you say y sub t minus 1, ang mangyayari dyan, mawawala yung una, no? Y sub t minus 1. So you're regressing our series on its past values. Okay? So, okay, let's assume that this is arranged from the lowest to the highest. The lowest to the highest. So this is the earliest. Nari, ito yung matagal na. Tapos, let's add more here. Nari 4. Okay, yung 4 yung latest. So, y sub t minus 1 will be, so what will be y sub t minus 1? So, you're going to regress this series. Ang gagamitin natin ngayon. So, yung past value, ano ba yung past value ni 4? So, 7. Ano yung past value ni 7? 6. And then 2. And then 2. And then 3. And then 5. Okay? So, this is now your y sub t minus 1. Okay, so what will happen is that you will regress y sub t on y sub t minus 1. Now, necessarily, mababawasan yung observations natin. Kasi if we're going to use y sub t minus 1, so ito yung y sub t natin, ito yung y sub t minus 1 natin. Gagamitin natin yung past values ni y sub t to model y sub t. Okay? So, we will have n minus 1 observations ngayon sa y sub t minus 1. Okay, so y sub t minus 2, paano yun? Y sub t minus 2, log 2. So, 1, 2. So, this becomes 6, 2, 2, 3, 5. Okay, 2 logs. No? So, lalaktawan tong 7, ito na. Magsisimula sa 6. So, if you're going to use y sub t minus 2, actually, mababawasan ulit yung natin, yung observations natin. Ito na lang siya. No? Okay? Y sub t minus 3. So, 1, 2, 3. Dito tayo magsisimula. Okay, ang isasali lang natin si 2, si 2, si 3, si 5. So, as we increase the lag, guys, mababawasan ng the more we decrease the number of observations. But if you have a long time series, okay lang yun. Okay, kunyari 5 years daily. So that's around 200, let's say 220 times 5, that's more than 1,000. So mawawala ng ilang observations. Okay? So that's what we mean by an AR1 process. So itong AR3, ito yung gagamitin natin. Imo-model natin si y sub t. This is your y sub t now. Okay? This is your y sub t minus 1. This is your y sub t minus 2. And this is your y sub t minus 3. So we are modeling y sub t based on its past 3 lags. No? Lag 1, lag 2, and lag 3. So that's the meaning of y sub t minus 1, y sub t minus 2, y sub t minus 3, etc. Okay, now back to my question. Nice. Clear ba so far yung sa AR process? Paki-chat naman please kung clear so far, kung walang question so far. Feedback please guys. Thank you thank you. Samir, thank you kanina. Yung 5 more guys, kamusta? I don't want to continue guys kung hindi maliwanag sa atin yung AR process, yung nagiging y sub t. Thank you Willie. Y sub t minus 1, y sub t minus 2. Steph, thank you. Okay, so I hope that's clear class na kapag nag-AR process tayo, siyempre mababawasan ng isang observation kasi nga gagamitin natin yung t minus 1 value. Okay? Yung t minus 1 gagamitin natin to explain your y sub t. Okay. All right, so let's continue. Okay, on the other hand, si MA naman, ang ginagamit natin yung error terms. No? Okay, an MA1, okay, minomodel din natin sa y sub t. Okay, but this time, it's now, so how do you write this? Annotate ulit natin. Okay, so y sub t is equal to, okay, so you have your error term plus, okay, usually they use theta 1 times error term t minus 1. Okay, so this is an MA1 process. So you use the error terms in order to explain your y sub t. Now, pag kinumbine natin si AR at saka si MA, for example, you have ARIMA 1,1, so you're now modeling y sub t as a function of, okay, you have a certain constant, mean or A sub O, plus your AR1, which is phi 1 times y sub t minus 1. Okay, so ito yung AR component natin, plus your MA, which is your epsilon sub t plus theta 1 epsilon t minus 1. Okay, so others would use the negative here. It's the same lang naman. So may makikita kayo pag if you're going to read up on this, you'll see that some models make this as a negative. Okay. All right, so this is your ARIMA 1,1. Of course, if I ask you, for example, write the model for ARIMA 2,3, okay, you should be able to write that, no? ARIMA 2,3. No? Ang ARIMA 2,3, ito yung P component, ito yung AR process, yung 3 dito, ito yung MA process. Okay, so that's ARIMA 2,3. Pag ARIMA yan, kunyari pag may nakalagay na 1 sa gitna, so that's an ARIMA 213. Ibig sabihin ng 1 na to, the series was difference, no? The series was difference by 1. Okay? Ano yung difference na series? So, explain ko rin yun, kasi para clear sa atin. So again, let's have another series. Let's say 6, 3, 5, 4, 4, 8, 3, etc. No? So ito yung latest natin, 3. So this is your y sub t. This is your y sub t series. Now, ano yung difference na dy sub t ngayon? So I'm attaching d here to indicate that our series is now a different series. So it will become now 3, i-difference natin. Ima-minus natin. So 3 minus 8, that's a negative 5. 8 minus 4, that's 4. 4 minus 4, that's 0. 4 minus 5, that's negative 1. 5 minus 3, that's 2. Okay, and 3 minus 6, that's negative 3. Okay? Notice you have now a totally different series na to. Ibang time series na to. Okay? That's now it's not the same as the original time series. So pag nagdi-differentiate tayo, class, you're generating a different. Hindi lang You're generating now a different time series. Okay? Tapos meron pang difference ng difference. So that's D2, no? So which happens when you have an ARIMA, let's say ARIMA, say 2, 2, 1. For example, ito yung series natin. Ito yung model natin, 2 to 1. Ang ibig sabihin ito, guys, yung 2 na to, ibig sabihin, you're differencing the series twice. So, dinifference muna natin to, which results into this one, and then, i-difference ulit natin yung different series. So, that's negative 5 minus negative 4, that's negative 9. Okay? 4 minus 0, that's 4. 0 minus negative 1, that's 1. Negative 1 minus 2, that's negative 3. 2 minus negative 3, that's 5, etc. So, this is now the series that you're modeling. Okay? So, magkaiba na yung y sub t natin sa difference sa y sub t, sa difference and difference sa y sub t. You're practically modeling a different time series. Okay, so just take note of that, class, na pag nagdi-difference tayo, you're actually working on a different time series. Don't think that it's the same series. So, later on, pag nagpe-predict tayo and you're using this model, iba na to. No? It's not the original model. It's not the original time series that we were working on. So there's a way to revert back to this. Okay, but we'll go into that later on. No? Pero just remember that pag nagdi-differencing tayo, which is the I here in ARIMA, you are dealing with a different time series. Okay, pause muna ako ulit. Clear ba tong difference na time series? Class? Paki-chat naman, please. Appreciate your feedback. Sabir, thank you. Thank you. Yung, salamat. Okay, let's wait for the others. Baka may questions sila. Steph, thank you. Jeff, yan. Willie, thank you. Okay, parang hindi yata nakukompleto yung pagko-comments. Okay, so I hope that's clear, guys. No? Pag nag-aarimat, pag nag-i-integrated tayo, pag nag-difference tayo, ito ngayon yung minomodel natin. Ito na yung gagawa natin ng AR process at saka ng MA process. Ito na. Hindi itong series na to. Okay? So you'll have a different, you're actually modeling a different series already. Okay? But you might ask me, why will we do that? The series that we want to study is this one. Okay, that's a good question. No? If that's your question, Now, that's a very valid question. However, since okay, why do we difference? We difference because the series is non-stationary. Okay, so if the series is non-stationary, then we cannot use Box-Jenkins approach on that. So if you really want to use Box-Jenkins approach, then we have to do the uh, required transformation in order to convert the series into a stationary time series. And then after it's converted into a stationary series, then we do the ARIMA process already. Okay? Okay, but there's a way to revert back to the original series at the end. Okay, so let me clear this. Okay, so last time we looked at uh, what a stationary time series is. Okay, let's once again, let me run this. Yung air passengers natin. So dito na lang. Okay, so okay, air passengers. Let me rename it into AP and then view. Yan. So si AP, no? So yung bagong version ng R, hindi nag-view ng ano, hindi pinapakita ng In your case, guys, are you able to see the kahit na view ko siya, no? Ito pa rin, no? Okay. Pag click ko to, it does not print. I will have to check kung bakit hindi niya pinapakita sa isang spreadsheet. Ayaw. Okay, in your case, class, does it show yung spreadsheet dito? Feedback please, guys. Nakikita nyo ba yung data natin? Okay, si Willie ganun din, no? Okay, sige. Thank you, Mariel. I think it's because of the new, ano? Kasi pag nasa lumang version naman ng RStudio, okay naman siya, nakikita naman siya, same. Okay. So, okay, we just have to siguro discover na lang natin kung bakit hindi nagpe-print. Pinapakita lang niya yung ano, yung values. So, anyway, so let's take a look at the structure ng data natin. So this is a time series. Okay, this is a time series. And then, ilan yung this function tells us, isasum natin yung is NA dun sa object natin na AP. Okay, so good, walang missing values. Otherwise, guys, in modeling, oftentimes you will need to do some imputation. Okay, what's imputation? Imputation is kasi may mga functionalities na hindi mag-run kung may mga missing data. So ano yung gagawin natin sa missing data? Pag sa time series, hindi naman natin pwedeng tanggalin na yun. Kasi parang mabubungi yung data natin. So what we do is to impute. Impute. Ibig sabihin ng impute, magko-compute tayo. Pwede ang gawin niya, compute yung median ng buong time series. Tapos yun ang ilalagay niya dun sa in lieu of the missing value, lalagyan niya ng value niyon. Either usually yung median. Okay, but there are other ways to impute it. Okay, so frequency ni AP, so that's monthly daw kasi time series siya, no? Then summarize nga natin. Alright, so we have the minimum, ito yung median, no? 265.5. Ito yung sinasabi ko kanina, pag may missing values, usually linalagyan pa rin ng pwede natin ipa-impute and ang common na ginagawa, pinapalitan siya ng median. So what happens is that the median still remains the same. Yun pa rin siya. Okay. And then the minimum and maximum will not still change. Kasi ang linalagay naman natin yung middle value. Okay. So we started asking this question, di ba? Is the time series stationary. So let's run the second one using the GG45, using the autoplot. This is just a very quick review of what we discussed so far. Okay, so sabi natin na definitely the object, the data is not a time series. Why? Bakit hindi sa time series? Unang-una, may trend yung data natin. There's an upward trend. Sabi natin ang stationary time series behaves this way. Okay? Walang trend, no? Walang trend. So average, yung mean niya is constant over time. Ito guys, yung mean niya, it's not constant. It's increasing over time. So for example, if you take a look at this portion here, maybe the average is this one. Pero pagdating na sa portion na to, average yan dito na. So the mean is changing over time. So that's what we mean by trend. And secondly, if you take a look at our data also, yung variance ay hindi constant. Diba? There is a fanning out. Over time, nag-i-increase yung difference ng high point natin at low point. Okay, you can see here that at initially maliit lang yung range ng between the minimum and the maximum values, but over time it's increasing. Okay. So this data is not stationary because there's trend and also there's non-constant yung mean, okay, and non-constant yung variance. So that's what we mean by having a trend. Ibig sabihin no, non-constant yung mean and having non-constant variance, which means na over time, no? Meron tayong seasonality. Okay, then we do the box plot. So kita natin dito, no, na on what month makikita natin dito yung mataas yung volume ng passengers. So we did that last time. Okay. We can also decompose the data using from the stats package. Okay, we can use the decompose function where the data will be decomposed into its yung original data, tapos yung trend, yung seasonality niya, and yung random data. So whether we use additive or multiplicative. Okay. Okay, I think we stopped here last time. Okay, so what we'd like to do now is to move on to the process of modeling our data. Sabi natin, we cannot model our data, we cannot model our time series if it's not stationary. So obviously, by looking at the plot, makikita natin talaga na hindi stationary. No? Now, there's one measure, yung autocorrelation, na importante to test statistically yung stationarity ng time series natin, ACF and PACF. Kasi stationary time series natin kung walang autocorrelation among the different lags of the time series. So makikita natin kung i-plot natin yung autocorrelation plot, makikita natin kung may relationship, no? Kung may significant relationship between lags, LAGs, of the data. Kung may significant relationship siya, ibig sabihin nun, then hindi stationary. Okay, so we can use this. Okay, yung autoplot, this is your ACF, autocorrelation function. Data natin is 80, then lag.max hanggang 30 lags. So titingnan niya kung si time 1 related ba siya kay time 30. Okay? So let's plot this first, ACF muna. Okay, so we can see here, guys. So very significant, no? Itong blue line na to, yung blue dotted line na yan, kapag lumampas dyan yung autocorrelation, ibig sabihin nun, significant yung yung correlation. So this is times 0. We expect that to be 1, no? Kasi the data is correlated to itself. But what about yung data with lag 1, yung time t minus 1? Yan. So autocorrelated siya, no? Significant to. How about with time t minus 2? So ito yung different lags, no? Hanggang lag, hanggang lag, hindi nakalagay dito, no? But this must be lag 30, no? Significant pa rin, no? So you can see here, significant yung correlation, yung autocorrelation at different lags. So this indicates that your data is not stationary. Even sa PACF, ganun din. Ito sa partial autocorrelation function, ganun din. Makikita natin na may mga significant spikes. Lag 1, 2, 3, 4, 5, 6, 7, lag 8, lag 12. There are significant spikes, which means that the data, our time series, is not stationary kasi may mga significant autocorrelation. Okay? Significant autocorrelation sa iba't ibang lags. Lag 1, lag 8 yata to, lag 12. Okay, so based on the ACF and the PACF, we can see that the data is not stationary. And we said we can use this, no? Ito, just use the ACF and the PACF. Same plot as above. Ito kasi ginamit natin yung autoplot function. But let me skip that. Ang pinaka mabilis, guys, itong from the TSF package. So we just use the autocorrelation function and then plot this, and then it will automatically give you the two plots. So this is just the same plot that we showed a while ago. Yeah. So indicative to, based on, so number 1, tinignan natin yung plot ng time series. May trend, may seasonality, non-constant, ibig sabihin non-constant mean, non-constant variance, ibig sabihin not stationary. And then secondly, we looked at the autocorrelation function. So this is the ACF. Yeah, ACF, and then this is the partial autocorrelation function. Both indicates that the data is not stationary. Okay. Okay, so ang question ngayon, paano natin gagawing stationary? So these are the steps that we need to undertake in order to make the data stationary. Okay, if the data contain a trend, okay, we can fit some type of curve to the data and then model the residuals from that fit. Okay, so sorry, I skipped, no? So pag yung time series daw may trend, ang pwede natin gawing, i-difference natin data natin. Okay? So remember, kanina pinakita ko, no? Ano ba ibig sabihin i-difference yung data? Ima-minus natin yung value at time t dun sa time t minus 1. So value at time t minus 1, ima-minus natin sa value at time t minus 2. Okay? So we're going to create another data now. Difference time series na to. Okay, so remember I mentioned that a while ago. So pag nagdi-differencing tayo, we're now modeling a totally different data. Hindi na to yung original data natin. So we have to do that in order to remove the trend. Okay? You can, as I showed a while ago, you can difference more than once. But usually one difference is usually sufficient. Okay? So, let's see. Let's illustrate that. No? Kunyari yung ano natin, ano, yung let's create another object, DAP, alt minus. So this is difference AP, and the function is diff AP. Let me just illustrate this. No? So ito, guys, DAP, just to show you. Okay, tapos i-view natin. Ay, hindi na naman natin makikita. Let me just try. Okay, wala na naman. Okay. Sige, ganito na lang. Let me just highlight this. Let me just illustrate here, guys, kung ano nangyayari dun sa ano natin, sa data natin. So let me head AP yung first 10 values. Okay, head AP. Now let me get head of the AP 10 values. Okay. Take a look, guys, at the DAP dataset. Ano nangyari? Nawala yung January, nawala yung pinaka huling-huling data. Okay, and then what happened? You now have a new time series. How did we get this? Mina-minus natin. 1118 minus 112, that's 6. 132 minus 118, that's 14. Ito yun. 129 minus 132, that's negative 3. 121 minus 129, that's negative 8, etc. So you notice that the DAP, the difference AP, is a new time series. Okay, kunin natin yung tail. No? Tail ng AP is, let's get the first 20, and then tail DAP, sige, 20. Okay. So let's take a look at this, guys. So ito si AP, no? Yung unang value natin dito is 432. Pero dito sa DAP, hindi na 432. So it's now 432 minus 390, diba? That's 42. And then 390 minus 461, that's negative 71. Okay? So nakita natin dito is na yung bagong data set natin, yung bagong object natin na DAP, it's now a totally different time series. It now starts with 42, negative 71, negative 47, negative 98, which was generated by getting the difference of succeeding values in your AP data. Okay, so ibang data na yan. Okay? Clear ba yon, guys? Paki-chat naman please. Clear ba yung difference sa data natin? Waiting for your response, class. Clear ba yung what happens when we difference our data? Pa-feedback naman please. Any questions? I need your feedback, guys. Kailangan clear sa atin to. Ano nangyayari dun sa differencing? Okay, thank you, Samir. Okay, the rest. Let's wait for the others to give their feedback. Any questions? Yes. Thank you, Willie. How about the others? Yung salamat. Jeff, thank you. Okay, don't hesitate, guys, to ask questions to seek clarification. I want us to understand what's happening when we difference a data. I haven't seen the responses of 4 others. Kamusta yung apat, guys? Clear ba yung ano natin? Okay, thank you, Mariel. Thank you. Okay. All right, good. Good. Okay, just to make clear, guys, sige, gawa pa tayong isang differencing, no? DDAP. So ito double na differencing na yan, no? DDAP alt minus. Okay, and then it's a we difference again yung DAP. Okay, di ba class? Ito naman ang difference natin si DAP. Okay, or another way to do it is difference and then difference of AP. Okay, so let's generate this and then head na lang ng tail na lang para ma-compare natin sa tail ng DDAP and then let's get just the first 10. Okay, now take a look, guys. Si DDAP ngayon is the difference of your DAP, which is this one. So, nangyari, pangalawang differencing tayo. 42 minus 71, that gives us 113. Negative 71 minus 47, that gives us negative 24. Okay, negative 47 minus negative 98, that's 51. Yan. So, this is now your difference ng AP. Okay, so as I mentioned a while ago, this is a totally different time series now. Okay, let's try to plot, see what happened. Copyhin natin to. No? So let's just replace this. Ito, i-replace natin tong ano dito, no? Let's see. Just replace this class with DAP, no? DAP. Okay, babalik na natin sa ano sa AP mamaya ulit, no? So, I'm plotting now DAP. Okay. Let's plot this. Okay. Notice what happened, class. Can you tell me what happened to our plot? What happened to the plot? You can unmute yourself, class. Anyone? You can chat. Ano nangyari dun sa ano natin? Sa plot ng DAP. Yung AP kasi kanina, ba? May trend. Itong DAP, what did it address? Hello, guys. Any comment? Comment, please.
Pero naging stationary na po.
Hindi pa stationary, pero nawala yung trend, no? Now, hindi pa siya stationary. Bakit? Kasi, okay, annotate natin. no more trend, no? Nawala yung trend. Okay, if you get the mean, yung mean niya naging constant na. Hindi na siya pataas, hindi na siya pababa. However, ano pa yung hindi constant? Non-constant yung variance niya, di ba? May fanning out siya. Yan. Okay? So, the differencing addressed the problem of trend. Okay, however, it did not address the problem of, hindi in-address yung non-constant variance. Hindi pa rin siya stationary. At least nawala yung nawala yung trend na. Pero may fanning out siya. Tingnan natin. The variance is not constant. Okay? All right. Good. Thank you for that answer, Sinem. Sorry, Mariel ba yan? O is that?
Ariel po, sir.
Mariel, okay. Thank you, Mariel. Yeah. Tama yung Tama yung partly answer mo na address yung trend but not yet the non-constancy of variance. So we need to address this also. So i-clear ko muna to. Okay, ibalik ko lang yung AP dito Okay. Run ko lang ulit siya. Tapos kita natin, di ba? Ito si AP. May trend siya. No? So, nung nag-difference tayo, nawala yung trend. Kahit na, subukan natin yung double, DD, di ba? Difference. Tingnan natin kung ano mangyayari sa plot natin. Okay. So, ganun pa rin, wala pa rin nawala ng trend doon. Pero meron pa rin hindi pa niya na-address yung non-constancy of variance. So, generally, differencing the data will address the trend, but it will not address the non-constancy of the variance. All right, so let's go back to what we were discussing. So to address the trend, we can difference the data. Okay, usually one differencing is sufficient. Okay. All right. Now, pero hindi pa natin na-address yung non-constant variance. No? So, for non-constant variance, we take the log or the square root of the series. Okay, pwedeng ma-stabilize yan yung natin, yung data natin. Pwedeng matanggal yung non-constancy invariance. However, you cannot take the log of a negative number. No? So let's see. For example, I get log of 100. Ito pwede to, no? Log of 100. Pero log of negative 100, that cannot be. Hindi pa pwede. You cannot take the log of a negative number. So, just take note that if your data has negative values, then magkakaproblema ka. Kasi hindi tayo pwedeng kumuha ng log ng negative number. So ano yung usually ginagawa dyan? Tina-transform natin yung data natin. Kunyari, hahanapin natin yung pinakamalaking negative. So, yung pinaka-minimum na number. Kunyari, ang pinaka-minimum niya is, let's say, negative 15. Example lang yun, no? So, ang gagawin dyan, magdadagdag ng kunyari, plus 15.1, for example. Okay? Dadagdagan natin yung series natin ng 15.1. Bakit ginagawa yon? Para mawala yung negative. Kasi negative 15 plus, bakit 15.1? Para maging positive to. Okay? Kasi pag 15 lang i-add natin, 0 yung lalabas yan. Di ba hindi pa pwedeng log ng 0. Yan. Take a look at that. Okay? So you cannot get the log of a negative number. You cannot get the log of 0. Kailangan yung range natin, dapat positive yan. Okay? Alright. So, may question ako sa inyo. Okay, our series has trend and seasonality. So, paano natin tatanggalin paano natin tatanggalin yung non-constant mean, non-constant yung variance? Okay, what we did a while ago was we tried to address the non-constant mean. Okay, so when we did that, nag-difference tayo. Ito si difference natin, no? Difference AP. Pag nag-difference tayo, chances are magkakaroon ng negative yan. Di ba? Kasi yung mga values, minaminus natin yung mga succeeding values. So, when we get, okay, so let me do this. I'm creating this object L, D, A, P. That signifies log ng DAP. If I get the log of DAP, what happens? What happens, class? Check nyo nga. What will happen if we get the log of DAP? So please give me feedback. Paki-chat please or unmute yourself. Ano nangyari? Guys, any feedback? Di ba may object na tayo na DAP? That's a difference AP series. And then, we plotted it, lumalabas na nawala yung trend. Constant mean na siya. Pero, non-constant pa rin yung variance. So what will happen if we get the log? If we will get the log of our difference AP data. Hello? Sige, let me ask. You, did you try?
Trying mo po, sir.
Sige, I'm waiting for your response. Ano nangyari? Type mo lang yan. Kasi ginawa mo na ba yung DAP? Trinay mo na, nag-create ka na ng object na DAP, yung difference na air passengers na data natin.
Yeah, looks like hindi pa po, sir. Kaya nahanap ko po saan yun.
Saan? Sige, iba na muna. Guys, sana sinusundan niyo yung process kasi pag hindi niyo susundan, mahirap, no? Iba yung nakatingin lang kayo, iba yung pinatype nyo rin. Jeff, how about you?
Yes, sir. I wasn't able to chat lang po kasi I was eating po.
Sorry?
I understand the lesson po. I wasn't able to chat kasi I was eating po, sir.
Hindi ko makakuha, no? Okay,
Yes, type.
sino yung sino yung nakagawa? Sino yung Yung, how about you? Did you get the log of your difference data? Ito, yung code natin na to. Log ng DAP. It's better, guys, to follow along. No? Anyway, you have the RMD file. So, kasi iba yung nakakapag-practice kayo na kinocode nyo rin. Hello, guys?
Okay po, sir.
Yeah? Oo. Ano nangyari? Sino nakagawa nito, guys? Nakakuha ng log ng DAP. Anyone? Willie? Okay, let's see. Jeff? Okay, sige. Okay, thank you, Jeff. Thank you for your... Okay, sige. So, si Willie, naka-ano ba? Willie, naka-ano ka? Nagawa mo? Willie, are you there? Sam? Ala, mukhang wala yata sa inyo nakagawa. Sam? Hello, Sam? Steph? Steph, hello? Wala ba nakagawa? Samir, how about you?
No, sir. I'm still trying to do it.
Bakit? Ano lang yan guys yung may AP na tayo, no? Ang suggest ko sa inyo guys, follow along. Mahirap yung yung nanonood lang kayo. Kaya pala walang sumasagot kanina pa na kasi okay, I'll give you 5 minutes guys to sige, pause break na muna tayo. Kasi it doesn't make sense for me to continue coding this na hindi nyo sinusundan. So let's have a 5-minute break. Dito na tayo mag-break. Tapos let's continue when you're done loading the other codes yung sa ginawa natin. Okay, so stop share muna ako.